This is Paul, the SDR guy, and in today's video we're going to show the Nooelec Goes Mesh Antenna. We're going to show the assembly and my modifications. This is episode 23 and I am the SDR guy. And I have collaborated with a good friend of mine on this particular video in putting the antenna together and all of the associated parts that you're going to be seeing in this video. Now, it's been a little while since I put out any videos, and the reason being the next few videos that I'm going to be putting out are going to be about satellites. Well, I'm new to satellites, so I've been undergoing a very big learning curve, and I'm now at a point that I can start sharing lessons learned with you. I received the image you see here using the antenna that we have built, and I do want to make sure you're aware that I did use Sanchez software to enhance the colors. And I'll be showing you exactly how to do this in the next video. Here's what the final build looks like, and this is how I had it oriented to capture the image that you saw on the prior slide. Well, what all parts did I use for this? Well, to begin with, I used the Nooelec Goes Mesh Antenna, and I wanted a tripod that was stronger than a normal camera tripod, so I purchased a stage speaker stand tripod. I also wanted to be able to easily and quickly and accurately get the elevation set right when I was aiming this antenna. So I purchased a digital angle gauge. I also picked up socket arm, a couple of 38mm balls, and optionally I picked up a 1/4-inch galvanized hardware cloth and some stainless steel safety wire that I used to attach the hardware cloth. And then lastly, I purchased a magnetic compass so that I could set the azimuth for wherever I was pointing the antenna. And I purchased this Goes Nooelect Satellite Mesh Antenna from Amazon. Cost about $100 US. This is the stage speaker stand tripod that I ordered from Amazon. I did some research and ended up choosing the Klein digital angle gauge. Again, purchased that on Amazon. Here is the socket arm that we are using, and I ordered a couple of these 38mm balls, again from Amazon. I went to my local Home Depot and I purchased 1/4-inch galvanized hardware cloth. Now this is optional, but I will tell you how it worked out, I guess, a little later in the video. And I used this stainless steel safety wire from Amazon to attach the hardware cloth. And here's the magnetic compass I ordered from Amazon. I didn't bother to show you the precise one I ordered. Pretty much any one of these that Amazon has should work fine for you. The first step in the process is to assemble the mesh antenna. I will put the Nooelec assembly instructions link in the description of this video. I tried to do this myself initially and it was just too difficult. So my friend helped me with this. So I strongly suggest that this is a two-person job to put this together. It's easy to put together, but you just need the four hands to do it. I needed to calibrate this Klein digital angle gauge, so I used a torpedo level, and I made sure that the surface was level, and then I followed the Klein directions to calibrate. This next step in the build is arguably the trickiest part of the whole thing. You need to make a plug that goes into the speaker stand tripod. In my case, a piece of aluminum was turned on a metal lathe until it would fit into the end of the speaker stand. A lip was left on the plug, and the reason why the lip was left was so that the plug did not slip down into the speaker stand. Next, a hole was drilled and tapped to receive the ball threads. Lastly, a pin was put through the speaker stand and plugged to keep the plug from moving. Here is the top view of the plug, and based on the resources that are available to you, you may need to come up with a different idea of how you can come up with a plug that will allow you to screw the bulb into. But this is what I used, and it works very nicely. Here's a side view of the plug with the ball screwed in, and you can notice the little lip at the top. The lip is just a little bit larger than the diameter of the speaker stand tube, and then a drill press was used to drill through the speaker stand and the plug, and then a pin was put in there. And this was done to make sure that the plug did not rotate. And here's the end of the speaker stand with the plug and the arm. And on the Nooelec antenna bracket, you can see the other ball is there, and that ball there will of course attach to here. And here we see the antenna mounted. On this side you can see the speaker ball, and I do want to tell you this: I did not cut any new holes in the Nooelec bracket, just used the original. And take a look here. There's a wing nut and a little piece of angle iron that's on the other side. And here's the view from the other side. And this is a piece of angle iron, and it needs to be magnetic, and then I'm just using a screw and a wing nut to hold this on. And this is the back side of the screw that's holding on the ball that you saw on the prior slide. And the Klein digital angle gauge has a magnet in the bottom of it, and it firmly attaches to the little angle iron bracket that I showed you. And here it is again. Next, we discovered that this thing would be better if it had a counterweight. At the angle that I need to tilt, which is around 47 degrees, I found that I needed about 1.5 pounds counterweight, and a piece of angle iron was cut and drilled 3 holes in it, and attached a counterweight there, and that works very, very nicely. And in this particular slide, we're showing you mounting the hardware screen on the side of the antenna that faces the boom and the feed, and I used a safety wire to attach this. if you decide to put this hardware cloth on, if you don't already have safety wire pliers, you may want to consider purchasing an inexpensive pair because it makes this job go much faster. I did test before and after, and this hardware screen did improve the signal strength. And here is the final build, and it's oriented in the manner that I need to be able to receive images from the GOES 19 satellite.